Oxygen, copper, aluminum, iron, oxygen, nitrogen, all of them are not fixed. But here we have fixed three things. We have copper, aluminum, iron. Here there are types of particle compound. Types of particle compound, like here we have two or more elements combining to fix it to each other, so that compound is containing two or more fixed particle. Like here, when we have an hydrogen with oxygen, and it that gonna make water. So here we have compound, that compound containing or consists or formed from two or more element that fixed, and the properties of two are different than that which are containing. So when we seeing here, we have two things making water. What are there? We have here hydrogen and oxygen. They are formed water. So what are the compound from what I said?
Hydrogen and oxygen.
They making,
Water.
yeah. So here we have types of particle for making compound. When we have a mixture, so we had saying about first one is element. Element containing one thing. Maybe that containing two particle like seven element. Maybe that containing one particle like all other compounds or all other elements. Here we talking again about the compound. Compound containing that making from any or formed from any two atoms which are different with unfixed bonds. What about a mixture now? We talking about here that are at least two substance. So now mixture are making from two substances are mixed together. So when we have here a mixture that are substance what are mixed together, but did they making any chemical reaction? No. So mixture had gonna be no chemical reaction or anything take place. Only they are mixed together. So even if it was element, even if it was compound, both of them are have in one container, but there no any chemical reaction. Again, when we having a mixture, that meaning we have to mixing thing, and both of them are not uh, have any chemical reaction. So we have that element compound or element or compound have can be have its properties. That mean like oxygen, it was a gas. So gas in water, that mean oxygen in water. So the fish can take in this gas. When we have mixture like our atmosphere air, that has what that has the gas of oxygen, nitrogen, hydrogen, all of them are mixed in one thing. But here, all of them, when even if they are mixed, all of them, we can separate each other from the other one. So we can take oxygen alone, we can take hydrogen alone, we can take a nitrogen alone by separating them. So mixture, we can take each particle from other one, yes. But when it was chemical reaction, is that easily to separating each other?
No.
No. So we know we having that mixture like an here we talking about a atmosphere air or anything, so that we having an area and the different thing. So we can separating by physical means. Like here we have a changing in temperature. Second thing, using magnet, like when we have a rust or iron filled in and sand like that, we can separating both of them by a magnet. Sometimes when we have a solving or anything to solve it in water, when we can separate it by evaporate the water. Like we have here a salt in water, and that salt we need to separate salt from water. What should we do? We should evaporating water, and when we evaporated water, that here we will still only the salt inside the bottle, but all other things it was stilling as it. So vapor water is gonna be, but still here the salt. So we when we had a question about the things which dissolve, we can separate it by evaporate. Is that clear, Tarnim?
Yes.
So when we have here two things, there is more type of an atom. Here we talking about an element like what here is an element are their atom chemical bond. So firstly, when we have more than one type of atom, that means that atoms are chemically bond. When it was no bonds, that mean there are mixture. When it was they are have a bond, that called compound. On the other hand, when we have no different atoms, only one atom, that called element. And element, if it has bonds, that mean it was molecule that containing two or more than one. When it was have one atom, that mean it was atoms. So we have different things. At first, when we're talking about water or there are like water only, it was have bonds that containing two things that mean it was an compound. When we have a mixture of salt with water, that both of them there is no fixed bonds, that mean it was mixture. When we have that only oxygen and oxygen containing two particles, that mean it was molecule. What about it was containing one thing like silver, gold, many things, that it mean it was an atom type. Here we have how to tell if it water is pure. That mean is that water can be not pure, Tarnim?
Yes.
Yeah. How did you know about it? Is that
Water can be on.
unpure? How?
It has like substances that are not supposed to be there.
Yeah. Like when we have a particle in water and that particle in water are we can see it or we cannot see it. Both of them that mean water is not pure. Sometimes it have a germs we cannot see, but it was still not pure. So if we can see particle in pure water, that mean you would only see water molecule. So when water containing minerals, that mean that water not pure. Impurities of water, that the substance will affected properties. So When it was containing other things in water, that means that water is pure or impure?
Unpure.
Impure. And that impure that has an affecting particle. So when we have here, for example, they are may be changed in boiling water, yeah. So when it has boiling point and that boiling point is increasing or decreasing than when it was pure, like when we know that pure water evaporating in 100. So that mean when it was evaporate at 130, that mean water pure or not pure? It evaporate at 100 when it was pure. So evaporate at 100 when it was pure. When it was evaporate at 130, that mean water pure or impure?
Unpure.
Right. So we have here that pure water evaporate or boil at 100, and at zero it was become ice. So that means it was impurity if it was changing. We have here an introductional about distillation and water chemical, and here experiment. Let's go. Like here, we can separating the mixture of frictional distillation. That in foil, you know that one only petroleum or oil, it containing many things too. So it was here having basil, having oil, having waxes, having kerosene, has gasoline or ethanol, and many things. So that mean we can separating mixture, yes or no?
Yes.
Yeah. At the first thing, we can separating it. It was by that the boiling point. So the only thing we can separating the mixture, it was by the boiling point. Here we can separating mixture too. Here that heat and we have a vapor, and this is called solution here, and there is a vapor. What will happen? It was cold water upside here, that cold water, and here we have condenser, we have cold water too, we have thermometer, and we have here and distillation. So that we can changing the water, yes or no? Yes, we can. How? Here we have a mixture, and in this mixture, we increasing the heat. Then, when we have here a vapor, so the vapor, it will be gonna here and be separated at the end. So, salty water, like sodium chloride solution or water, all of them are distillation at the end. So it was distilled by the vapor. So here, when we increasing the heat, that the water will become vapor. Then it was distilled at the end. So now we can separating water, yes or no?
Yes.
So what will still at the end of this separation in this flask?
Salt.
Salt. Yeah, you are right. We have a types different separation. Here, there is was separation. Here, and this is called distillation 2. So this distillation 1 and 2. So now we have a round glass or round bottom glass. And here we have a flask and condenser, water, vapor, and many things. And there up we have always that thermometer. So we can separating the mixture of liquid such as ethanol and water. Yes, we can. How? Ethanol boils at 87, 78 Celsius and water at 100 Celsius. So both of them are mixture. Then it was the water is their mini condenser. Then it was at the end. What happened? All of water and all of ethanol. All of water is still in the flask here, in round flask, but the alcohol, because it was lower in boil, so it was become here. So we can distillation everything, yes or no?
Yes.
So can you uh, repeat it? That's distillation too for me.
Uh.
We have two things at first. This water and ethanol, right?
Yes.
What happen if we increasing the boil till 78,
The ethanol boils and
right?
the water stays.
Right. So it's gonna be that the ethanol is going to that flask, right?
Yeah.
Yeah. What about that water? Where did he still?
It's still in the
Round bottom flask, right?
yeah.
So now we can everything separating by maybe we having two things like what? Like round bottom and the flask. Is here we only have two things. We have beaker and we have an flask. Only here using or a boil. Here we can filtrating both of them. The third thing, when we have a mixture, here we on using for this separation things which dissolve. So that called distillation. So distillation when it was dissolving. That mean mixture, no, maybe mixture, yes, but mixture when it was dissolving. But here, when it was not, it was a mixture, but not dissolving. That mean we can seeing the particle with our eyes. So that soluble or insoluble Tarnim now?
Um. It,
Insoluble. That means it was not soluble at all. That means we can see it by our eyes, like that. Here, water with sand. So both of them are mixture now, but both of them are not soluble in each other. So we're using an filter paper. That filter paper can distillate and separating the mixture here. And we having at the list only filtrating and residue. Both of them are mixed to each other to making the solution at the end. So now we can separating both of them, yes or no?
yes.
So what is the thing which are going from the filter paper? It called
residue and filter.
This, yeah, residue and filter it. Here we have separating mixture. It was crystallization. What is the crystallization? Crystallization is used to reproduce solid crystal from solution. So when we needing to make a crystal from a solution, it was called crystallization. So what is the crystallization again?
When you make a crystal from solution.
Right. We have here an separating mixture. This separating mixture, immiscible liquid. What does the mean immiscible? That is both of them is not immiscible or miscible. Mean that both of them are not have a layer between each other. You know, oil. When we put oil on a water, we have two layer or one layer.
One layer.
Where is the one? Between what and what? Between oil and water. Both of them can mix it or not mix it.
Not
Yeah, not mix it. So we have a layer here between water and oil. So that when it was, there are miscible. That means both of them are immiscible. But we cannot be, um, we call it not miscible at all. So it was immiscible. So when we have a water, oil and water and water oil and oil and water with petrol, maybe here we have a mixture in three things. Maybe oil and petroleum are mixed, but water mixed to petroleum or oil. Is this right or wrong?
wrong.
Wrong. So now we have no of number or no small scale. So on a small scale, like what? Like immiscible liquid that's separating by what? By the top of layer. So we have here two separating that. We using separation or separating funnel. So separating funnel, it's used for
Separating solutions.
yes, which are has more than one immiscible point, which are here we have a solid, liquid, and gas, maybe, or many things too. So when it was mixture, when it was having more than one, like here, we using what separation funnel. So we having now separating mixture. What is the separating mixture? Separating mixture. It uses by immiscible liquid. So it was made by immiscible liquid. So it was called chromatography. So it was called chromatography. It was used for separate dissolved substance. Tarneem, are you with me?
Yes.
You can take only 5 minutes as a rest. Let's just, we have here unseparating mixture. Here we have a chromatography. What is chromatography? It's used for separating mixture. Like here we have and different colors. Like here, this we have one color or different.
Different.
Different. So when it has different things or different color, like inks, you know ink, when you are have a pen inside a pen, which we are typing, it was ink. So we have that things inside. each other. This called an ink. Here it works for what? For substance or for something is colored substance. Here we have a dissolve. This dissolve liquid, but than mean only better than the further in water. So or in paper. Here we have a different things. Yes or no? Yes, we have. But we talking about that here, not now. He mentioned he will talking about next week. Sure, we can separate it too. So we have here sometimes we have compound or combine that more than one separation technique. So when we have that it was a rock salts, here we can containing impurities that we have here too. Things like what? Like rock, salt, mixture with hot water, many things like impurities does not dissolve in pure water or pure salt. Many things like filter or impurities. So we have here one type or many types, Tarneen?
Types.
Many types, yeah. Here, he said to us, what is the method we can use for separating sand with water and iron firm? Hmm. Can you tell me anything?
I don't know.
So, iron firm, iron fillings, it was can we can using magnet here to can separate. Why? Because it was uh, attracted to the magnet at first. So we can separating iron film with a magnet. We can separating water from sand by filter paper, right? So we have here three things. Firstly, we should separating iron film with a magnet. So we can again separating iron films with
Magnet.
magnet. The second thing, we can separating the sand with water by filter paper. So we can use it by again,
Filter paper.
right. So we have here two things. We can separating by filter paper or with magnet. Magnet for iron fill. Oh, he using at first. What he using the magnet for what? For that separating iron fillings from salt and water. Then, when we have that iron attracted to the magnet, this is one. The second two, we can separating water from that sand by filter paper or filter funnel with filter paper and conical flask. So we have here two things we can separating by. Is that clear?
Yes.
Let's go to the next section. Here, Starter about chromatography and black ink. At first, when we have a point of ink, then that point when it was touching water, so that the ink will go upstairs or downstairs, you will go upstairs. So that when we have an spot or point of ink, it was going up. So that separating, yes or no?
Yes.
And here we have a paper chromatography, like an ink, like an dyes, like an add additives, additives, additives. So we have here three things: inks, dyes, and additive. And paper chromatography, there are two phases stage of chromatography. Like here we have a mobile phase and stationary phase. The mobile phase here is moving phase, and in paper chromatography, this is usually water or ethanol. So when we have a mobile phase, it was that moving phases between two things in chromatography paper. There are usually water or ethanol. So when it was the stationary phase, it stays still. So in paper chromatography, the paper is the stationary phase. So we have two things again. We have a mobile phase and stationary phase. What are both of them? They are the two things or two stages when we needing a chromatography. So when we have a solvent and this solvent reaches an ink. Look here, Tarnim. This called baseline. This is a start. Here separating the dye and here the solvent front. So when we have a water now, so water will make them mixture, yes or no?
Yes.
Yeah, but we putting much water or less points?
Less.
Less. So we can using here and water, and this will separating the solvent inside. Here, analyzing of chromatography. Here we have a star. Look here. This point is a star. Then it was mixture. How many color in red dyes? We have three in red, right?
Yes.
So what about that violet?
3.
Yeah, all of them are different or the same.
Different.
What about we have a green? This green become he is a mixture. Yes or no? He is not mixture. He is only coming from mixing between two things. So now made using yellow color. Which dyes are made using yellow color? Is this made of green? So we having RF value. What is RF value? RF value is a chemical that are identifying what that the radiation factor. So RF is called radiation factor. So what is RF, Tarneem?
Radiation factor.
Yeah, it was a radiation factor, and this radiation factor is a ratio. That ratio of what of distance traveled by the sample spots. So we have here to the distance traveled by solvent water. So here we have at first a point here, then here, then there, and here. So everyone it was increasing or decreasing, so it has a distance. At first it was 2 centimeter, here 6 centimeter, here 8, here 10. So the solvent, the distance moved by the symbol over the distance moved by the solvent. So RF, it was the radiation or radiation factor. So by distance of what? Of move by sample. يبقى أنا عندي هنا if you asking us what is the distance moved by the sample, it was moving from the first point by the time it was increasing and moving away. So when he asking us the solvent from, here we have a point, and by the time it was increasing or decreasing, it was increasing and going away. So who is greater one? The color is called blue or purple, yellow or orange star.
Blue.
Right. So why? Because blue is moved by the sun. It was far away. Here, when we calculating RF value, that by what? That calculating by three spot. Like here, we have and first one. It was E 120 was 7.2 centimeters. Here E 133 it was 4.1. Here we have an E 124 it was 9.5 centimeter, and all of them are 10. So we have here and distance. So every E 120. The distance which moving is 7.2. Am I right?
Yeah.
So what about the distance which the solvent move? He moving 10, right? He moving till here. This is the end of water move. So we took 2 points. We took the point which there are and the point which water moved. So water moved till 10 centimeters. Here, the distance which the solvent making, it was 7.2. So we have here to calculating RF. RF equal 7.2 over 10. It will be 0.72. So RF equal 0.72. So is that clear?
Yes.
Here we have 133. So, and the distance become what? It was 4.1. So we have here the distance, and we have an amount of water. He moving till 10, right? Water always moving till 10 here in this question. So all of them, the solvent moving 10 centimeter. Is that clear?
Yes.
So we having here the second one. You can calculate it by 4.1 over 10. It will gonna be 4.1 over 10. It will be 0.41, right?
Yeah.
Yeah. So we have here RF, it will be 0.41. The third one, it was the higher one. It was E124. And it was moving till, what is the amount here?
9.5.
So 9.5. And the solvent always moving in this equation till how much is this called? It was 10, right?
Yeah.
So the solvent moving till 10. So I should calculating RF. Can you name do this?
0.9.
Right. How it come? It coming from 9.5 over 10. It will be gonna be 0.95. We have a sample of example or exam question. At first, during paper chromatography, why must you make sure the ink spot doesn't touch the solvent when you place the filter paper into the solvent? Why? Because when it touching each other, the calculating is that correct or not correct? Not correct. So when we calculating it, we should doesn't make the ink spot touching the solve. Okay. The second one, why do you place a lid on top of the container while carrying out paper chromatography? He's saying that we using that lid on the top container because both of them are moving by the time. So if we didn't move it, it will move by the time. So what is the pattern of spots product by paper chromatography knowing as? Chromatography, we know in chromatography as the points which have different color. So now when he said, how could you use paper chromatography separated more than one ink as in one single piece filter paper? We can use at first. You should firstly ink must washed by away by the solvent to the solvent evaporating a chromatography, and you could spot the inks separating by a different pointing along of baseline at simple base. Here we have a chromatography plenary discussion. Mhm. So we have here, can you thinking that issue can raise because that? So when paper chromatography are a small amount of sample being analyzed is based on a piece of chromatography paper to separate after analyzing the sample, the material that we being analyzed is not able to be relative due to this chromatography is condenser. So it was described that. So here, when we have a point and this point have two inks like this turning, look with me here we have a points and these points are different. So here it was 4.2. Here it was 6. Here it was 9. And the solvent reaching 10. Can you calculating RF?
0.6. and point 42 and 9.
Point 9 بقى because we always divided by 10, right?
Yeah,
Yeah, so all of them are different. So here we have an RF again. It will be the point of the solvent over the point of the solvent. So we have here the point one, it was two, here's three, here four, here five, here 4.3, here it was eight, and the solvent it was nine. So can you calculating the RF now?
yeah,
Or how much it was?
point 43 and
0.43 تمام okay. We have 8 and 5 and 3 and 4
4,
and 2.
5.3.4 and 2.
Yeah, all of them are points now because all of them are fixed in 10. But you didn't realize that solvent reaching 9 only, not 10. So we should made it 2 over 9, 3 over 9, 4 over 9, 2 over 9, 3 over 9, 4.3 over 9. All of them will gonna be over 9 or 10?
9.
9. Why 9? Because the 9 is the point which is solving fridge. Is that clear?
Yes.
Yeah, we had finished that. We can starting the next one because we have about 7 minutes. So we can start in. Here we're going to talk about atomic structure. Atomic structure is a proton, neutron, and electron. So when we asked you to talk about the atomic structure, it was what? It was the amount of proton, neutron, and electron to make up atom. So atom containing three things. They are called subatomic particles. So why these subatomic particles? Because they are smaller than atom. So the subatomic particles it was things which we colon by proton or neutron, or the third one it was electron. So here we have a particle. The mass, relative mass of proton is equal 1, and the charge is 1. Neutron is 1, and the relative charge is gonna be 0. So what about proton again, Tarnim? It was,
0.
yeah, it was 1, right? Relative mass, it was 1. What about the relative charge? It was positive 1. So what about the neutron? Neutron here, it
1.
was 1. Yeah. What is the relative charge? It was 0. Here we have the electron, the mass. Here it was 1 over 1,836. Wow. So it was super small. What about the charge of electron? It was positive or negative?
Negative.
Negative. So we have three things. We have neutral one. It's called the neutron. So N. So neutron is neutral. So we have electron is negative. So we have proton is positive. So B for B. Positive for proton. Neutron is neutral. En for N. So electron for negative. We talking about here atomic structure. Like here that ion of copper. Ion of copper, we have a mixture of what? Of three things. Like what? Like here it was neutral. Neutral means the number of proton is equal to neutron is equal to electron. So all of them is 6. Another negative one, it was 5 and 6 and 6. All of them are not equal because that it was negative. What about here? This atomic is positive charge. Here, because the electron is higher or lesser. The electron is only 5 and positive is proton is 6. So that proton is higher than electron. Here, that proton is lower than electron. Here is equal. We're talking about atom or molecule. So we have here an atom. And this atom is the smallest piece of an element that can still be recognizing as element. So we can, knowing that atom is still recognized by an element. So everything is still recognized by element. It's called atom. When we talking about a molecular, it is consists of two or more atoms and that are chemically bonding covalent by sharing electron. So it will convertly by sharing. We have the atoms that make up what element or molecule so can be formed by the element. So everything we have a different. Here we have the periodic table. Periodic table here called we have many things. At first, that atomic number it will be equal for proton. So here, Tarneem, we will go to talk about like aluminum. Aluminum is 13 and 72. So here, the number which are in the lower here, it's called atomic number. So the number here is calling her name.
13.
Yeah, 13. It was atomic or another one. Hmm,
Atom.
atomic. What about here? It was the mass number. So we have two numbers here, atomic number and mass number. Mass number is up here. That was 27. This consists of proton plus neutron. So proton plus neutron, it was in and mass number. What about atomic number? Atomic number is having that only number of proton or number of electron. So we have here three things. We have proton, electron, and neutron. What about mass number? Mass number is the number of proton plus neutron. What about atomic number? It is the proton plus electron. So proton plus electron is gonna making another thing. It's calling an atomic number. So today we had finished about 2.5 session. Did you understanding what we had said today, Tarnim?
Yes.
Yes. So inshallah, our session the next Friday, I will gonna ask you about what we had studied. Okay?
Okay.
Okay. Do you need anything?
No.
Goodbye. See you
Bye.
later. Bye.